Welcome, Jessica. Let's have a look. Brilliant. Okay.
Connecting audio. Awesome. Can you hear us?
There we go. There's a good song that goes, Jessica. Do you know that one?
The Afrikaans one.
Yes, Socky time.
Yes.
I'm afraid I don't have the button to play the song, but
You're more than welcome to sing it if you want.
no, it's not going to happen.
Jessica,
Welcome, Jessica.
Is it your first time with us? And is it Jessica? You can just unmute yourself.
Hi, now Jessica is the mom. Antonio is here. It's actually Antonio's class. He's working from my laptop.
Oh, no problem.
Thank you so much for sharing. I'm just going to rename him Antonio on the laptop or here in the chat. Well, welcome.
Welcome.
Hi, Antonio.
Where are you joining us from, Antonio?
From Ravensmead, Tigerberg High School.
Oh, lovely. Awesome. I'm in Fishhook. Now I say I'm in the deep south. People laugh, so I'll say I'm in the deep south. Cool. So Antonio, what we do at the beginning of a lesson, and we'll probably, me and Elzan will be sort of welcoming and talking to people for the first 5 minutes, is we have what's called the do now question, which should hopefully be on your screen. I don't know where you are in your studies and your classes, but basically we're looking at data and stats and probability. And so give the first question a go while we wait for everyone to join us.
Okay.
So it's a multiple choice. So that we can say like that's option A, B, C, and D. Okay, who else are we? Elzan, can you hear me okay? Is everything good with like bandwidth and all that? All good, okay.
Everything perfect.
I never know when my Wi-Fi is going to be dodgy, which is just obviously not what you want. So, okay.
Should I choose to answer? Should I answer to you?
So I'm totally going to give you a chance in a moment. I'm just going to wait a little bit longer before we start. So I'm going to pour, in fact, do you want to try out the chat stream? Can I ask you, Antonio, to put the answer in the chat stream just to see that you're familiar with it? And then just so we kind of try out all the tools and then we'll get going. Because sometimes during the lesson, what we do is we kind of go back and forth with the chat stream, and students will give answers, etc. And then sometimes they turn their mic on. It just varies. Cool. So I think we'll give it 2 more minutes, and then we will get going. And in fact, do I have another do now question below here? Let's have a look. Do you, Antonio, do you know what a percentile is? Or have you heard of something called a percentile?
No.
So what you could do for me is after you found the group that you think is the right, whatever one you think it is, if you could find me what's called the 70th percentile. And if you don't know what that is, I'll give you a little bit of a hint. If the median is halfway through the data, the 70th percentile is 70% of the way through the data. And you can even just think about like what you think that would be.
I'm confused. I don't know this percentile. I never heard percentile before.
Okay. Oh, I see all my people are back.
Yes, here comes in all the troops. Welcome, guys. It's awesome to see you again.
Okay.
Can we get
Well-
some emojis, how you guys are feeling?
Are you ready to climb the steps for this lesson? Where are you in the journey of life? Are you starting up here, or do you feel like you've climbed the mountain halfway today already? I think I'm just having fun with drawing again, but okay. Yeah, I'll keep those emojis coming. How are you feeling today so far? Okay, so for those of you who are settled, you've got your book, you've got a pen, you've got a calculator. The do now question is on the board, and that's the main focus. And for those who are really like, just, I've got this down, can you figure out what the 70th percentile is for this particular list? That is something which I've kind of added. Okay, Alzana, I'm about to start. Is there anything else you want to add or anything I need to know?
No, just wanted to tell the grade 11s, enjoy it so much, ask many questions, and then I'll see you guys again afterwards.
And just jump in if you think, if for whatever reason I'm not noticing something.
For sure.
Okay, cool.
Enjoy,
Welcome,
guys.
everyone. So I want to start with this do now question, and basically this is, as it says, basically a box plot, or box and whisker plot as it's called in South Africa. And you have to figure out which data set gave rise to this description of the data in the box and whisker plot. So, the data is sitting, let me just get a different color. So often in statistics, we're given a basic data set, and then we have to represent it graphically. And so that's what this question does. But in the last lesson, we spoke a lot about box and whisker plots. And so we want to see, can you figure out, go backwards, which data set would have given us this box and whisker? And I want you to put it in the chat. So there's 4 options, A, B, C, D. And so if you could just pop that in the chat right now, which one do you think it is? Then I'll give you a hint, and then I'll give you an answer. Okay, so Antonio's answer is locked in. Let's see if anyone agrees or disagrees. So just to get us moving, can anybody tell me what is special about that point, that point, that point, that point, and that point in a box and whisker? And this is a jump on the audio, mic thing. What's special about these 5 points? If we go back to the last lesson, I feel like Aiden, you're just itching to jump on the line, or Boitumelo, if you want to jump on, what's important about these 5 points? Okay, so these 5 points are the 5 numbers from the 5-number summary. So this is the min value. This is what we call quartile 1, quartile 2, quartile 3, and the max value. If you feel like, whoa, what's going on here, I would recommend looking at the previous video. But this is called the 5-number summary for a data set. And so there are 5 important numbers. And so if I'm looking at the min and max, that can tell me something about this data. So the max is 38. So actually, I can cross out that one already is the one that's gone. Then if I look here, my median is 32, my Q3 is 35, and my Q1 is 29. And I'm just looking at these values. Now, all I want to figure out now, and I'll try, in fact, for the sake of time, I'm going to bring up my answer here. But basically, I'm doing, let's see. Come on. It's always weird. Come on, thing. Can you guys see the answer here? So basically, you should find that if you look at the data set, you should have 30 and 34. So let's have a look. In the middle, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, all of these have 10 data items. And so using the formula from before to find the position of the median, I go 50 over 100, or a half times n plus 1. And in this case, that's going to give me position 5.5. Okay, so, and now if I count in my list, 1, 2, 3, 4, 5, 6, the median is basically going to be sitting over here, which is going to give me, what's halfway between 30 and 34? It's going to be 32. Okay, does that make sense to everyone? So now the question is 1, 2, 3, 4. It could still be A, and it could still be, let's have a quick look. Sorry, guys, I'm getting a little bit. So for me, the answer of B does look reasonable. Does anybody disagree before I kind of go into? I would have to check Q1. How would I check Q1? Let's do it. So if I want to find what Q1 is, Q1 would be between the second and third position. So that would give us a 28 for B, which I disagree with. Okay, so let me actually slow down here, because I disagree, I think, with B. The position of quartile 1 is going to happen when I go a quarter times n plus 1, where n is the number of items in the list. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, 11 divided by 4 is going to be, there's no shame sometimes in using your calculator, is 2.75, position 2.75. So it is going to be between, it's going to be over here, which means that the value of quartile 1, according to B, is 28. Now, on my diagram, Q1 is actually 29, so I disagree. It can't be B. And we had ruled out C because the highest value is 40, and in my drawing, the highest value is 38. Just give me a thumbs up if this is making sense to you, or if it's helping. I just want to make sure I'm not going too much detail. So just give me a thumbs up if it's sort of making sense. Give me a thumbs down if you kind of feeling a bit lost. Okay. I see a few thumbs up, so I'm going to boldly tread on. Okay, so now we left between these two choices, between A and D. Now, like I said, if I look at A, the position of, okay, something else I must point out is, can you see the data is arranged from smallest to biggest already? If that hadn't been done, there would have been problems, because all of this is based on this idea that you've arranged it from smallest to biggest. So halfway between the second and third one here is going to be 28.5. And that doesn't match what we call the lower quartile from up here. So I cross out that. And according to this one over here, what do I have? Between 28 and 29 as well. Okay. So what I think is happening in this question is, this is an American question, and they're using a different definition of the quartiles. And so there is this thing where how we define our quartiles is subject to there's some differences, but according to the logic that I've used, this is the process that we should be using. So basically, I'm going to move on from this question now, but I think that I've shown you the idea of how I would approach the question, basically. Okay, so that's how I would be checking whether or not it matches this thing. Okay, so just before we get properly started with the lesson, I would recommend having a calculator, having a book, pen and paper, and having some space to write and listen in. Okay, so make sure you've got that, otherwise it'll be difficult to concentrate. And then what I want to do is I want to do another question related to the previous lesson. I'm going to call this a review, and I'm going to ask you to do this question for me. So I want you to find the interquartile range of the box plot below. And once you've got your answer, then could you put it in the chat? So first of all, what is the interquartile range is the other question. And you need to think back to the previous lesson. Okay, I see some answers coming in. Let's keep them coming. So remember from the previous question, this is the min value, this is the maximum, this is Q1, this is Q2, and this is Q3. Now, in case you're wondering what is this man talking about with these Qs, this is just shorthand for the lower quartile. Q2 is basically it's halfway in the data. It's sometimes called the median, or 2 quartiles up, and Q3 is the upper quartile. And these tell us how much of the data basically fits in between. Each quartile holds 25% of the data. Okay, you guys know this. This is fantastic. So to find the IQR, you simply go Q3, which is a value of 6, minus Q1, which is a value of 2, and your interquartile range is 4. Now, what that means is that the middle 50% of the data falls within a range of 4. It's spread out over a range of 4 units. Now, I want to quickly, now that you've got that, what do you think it means that this side of the box and whisker plot, this whisker is so much longer than this whisker over here? And you can either put what you think it is, what it means in the chat, or you can jump on audibly. Is this just a mouse that shaves badly, or what does it mean that the one whisker is so much longer than the whisker on the lower side? Any ideas? What does it mean? How much of the data fits between the value 6 and 12? And how much of the data fits between the value 0 and 2 is maybe a guiding question I can give you. Any ideas? Or am I going a little bit too deep into math teacher land? Give me a thumbs up if I'm going a little bit too deep into math teacher land. Give me a thumb. Yeah. Okay. So all I'm trying to foreshadow a little bit stuff that's coming later. From the range 6 to 12, there's 25% of the data fits in that whisker. And in the category 0 to 2, so this area here, it also fits 25% of the data. It's just that things are much more squished together in the bottom part from 0 to 2. Basically, a whole lot of data fits into a much narrower area. And so when we talk about later on the distribution of the data, these whiskers are going to tell us something about how the data is spread out. It's almost like it's more spread out on the right and it's less spread out on the left. And that's all I want to point out to you at this stage. Okay, so you'll thank me for that a little bit later. Okay, so what are we doing? What is the main focus of today's lesson? So the main focus of today's lesson is something called grouped data. So often in statistics, when you're dealing with really big data sets, you don't work with individual items. Like if you're working in advertising or you're working in population censuses, you normally work with groups of data. And so we need to adapt what we know about stats to work with groups of data. And so we're going to spend some time on that now. And so I'm going to ask you to think about this question. I'm going to give you about 2 minutes to do that. And then you're going to put A, B, C, D, or E. And for those on the live stream or anywhere else on the internet, please vote as well. the basic information is that these are all islands from around the world, and there are many islands in the world. This is just a couple of them. These are their landmass areas given in kilometers squared. And so now, if you're thinking of intervals or groups of 250,000 kilometers squared, which interval has the most islands from this? And I want you to try and use whatever method you can to get an answer and then vote. What else do I need here? So we'll say I've just noticed something. Oh. Okay. Okay. Give you about another minute or so. Oh. Okay. Any answers? Are we ready to vote? If not, I'm going to go ahead and show you how this is done. But I just want to give you a chance to vote, or even lock in your vote while I'm explaining this. So often when we do this, we have a table that helps us. And so I'm going to show you that over here. So I've got my groups on the left-hand side, and then I've got what's called a tally. And then what we have is a frequency or a count. And sometimes you even see something called a cumulative frequency, but that's more for later categories. So I'm just going to say a little bit about it. So I think that Greenland would go into, let me cross them out as I go. I think Greenland would be in that category. New Guinea is going to be in that category. Borneo is going to be in that category. Oh, Madagascar. Wow, Borneo must be big. No, I've made a mistake. Have I? 751? No, I'm all good. Madagascar needs to get 1, 2, 3. Madagascar needs to go into this category. Baffinland goes into this category. Sumatra goes here. Honshu is going to be here. Britain is here. Victoria is there. Ellesmere is here. And so what we see is here. So 5, 1, 2, 2, 1. So if I've done this right, the total of my frequency column should match the number of islands. So 5 plus 1 is 6, 8, 10, 11. 1, 2, to see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Fantastic. Okay, so now that you've seen what I've done, can you vote now? Which of these categories do you think has the most islands? For which of these? Yeah. Give you a moment to vote. It looks to me like the first category does. And so we would say that in the fancy words of statistics, we would call this the modal interval. You notice how it has the word mode, like, before, the one that occurs the most often is called the mode. In grouped data, we call the one that has the most in it the modal interval. Okay, so that's something to keep in mind. And then just a bit of foreshadowing. Who has heard of what's called the cumulative frequency? So give me a thumbs up if you've heard of it, and give me a thumbs down if you've never heard of what's called cumulative frequency. So thumbs up is yes, I've heard of the word cumulative frequency. Thumbs down is, look, even if I've heard of it, I don't really know what it means. Okay. All right. So cumulative, okay, so I'm going to explain it. Cumulative frequency just means keeping track of how many items have occurred if we go from the bottom up. So in the first interval, the cumulative frequency is 5. In the second row, we add what we had before, so we get 6. Then in the next row, if we add the next one, we're going to get 8. Then we get 10. And then the last column in cumulative frequency, it has to match the total of the number of items. And so cumulative just means to build on or build up. So essentially, it's like adding the frequency every time. So what this tells us is that there are 6, let me use a different color. There are 6 islands at that point that are between 0 and 500,000 kilometers, because the cumulative frequency at this stage is 6. And we'll learn more about that at a later stage. Okay, so that was my little bit about introduction to group data. Are there questions about putting data into groups, or any comments that you want to make before I move on? Okay, sometimes in exams you have to do this. Some students don't know what a tally is. A tally is just a way of visually keeping track of what you're counting. And when you get to 5, you normally do a cross through 4 individual lines. And if I had gone to 6, I would have started another count of 5. So those are the sorts of things that you must jump on if you want to clarify as we go. Okay, so let us begin a grouped data question. Now, you'll notice that I have put things into a what's called a frequency table for you. Now, what I want to ask you first is, what type of data am I dealing with? When we're dealing with, so Zanele did a survey of 10 of her friends. You can imagine doing this. She asked them how many siblings they had, how many brothers or sisters. What type of data is she getting when she gets that information back from her friends? Does anybody know, how would we describe the data that she's collecting? You can jump on, you can put it in the text stream. What type of data is it? I'll give you a hint. Can I have 2.5 brothers? Can I have 2.5 sisters? No. I can only have 1 sister or 2 sisters or no sisters. So we call this type of data discrete, and it's quantitative data because it's in numbers, because it only occurs without sort of lots of little fractions. It only occurs in whole clumps. So this is discrete data. Okay, so I'm going to put 3 questions here. Question 1, 2, and 3. And I want you to tell me in the, basically in the, actually, let me do this whole one for you, and then you can do the next one. So when I'm given grouped data like this, and I'm asked, what is the mode of the number of siblings? I'm basically looking for the one with the highest frequency. So in total, we know she surveyed 10 of her friends. So one would imagine if we add up the frequency column, if we get the cumulative frequency, so 2 plus 3 is 5, plus 4 is 9, plus 1 is 10. 4 people said they had 2 siblings. So I have 2 sisters, so I would be one of those people. So the mode of the number of siblings, we would say it would be 2. So something to watch out for here is just the difference between the actual number and the count of how many of those things there are. And the count of how many of them there are, the fancy word is frequency. Okay, whereas the thing we count, the thing that we're asking about, it could be siblings, it could be anything, it could be elephants, it doesn't really matter. Okay, so now the next one is the median. How do I find the median of the data in the frequency table and the mean? And this is a bit more tricky because we don't have a list of items. So what we're going to do is we're going to think about, well, how many items are there? We know that there are 10 items in total, and we know that they're already arranged from smallest to biggest. So if I have no siblings, if I have one, it's already been arranged from smallest to biggest. The median has to be in the middle. So we're going to use the same logic as before. We're going to say, well, what is the position of my median? Or the median is also called Q2. What is the position of Q2? Well, we know to find its position, we use this formula where n is the number of items. So we go, and I'm pretty sure that that is position 5.5. Okay, so that's not the value I'm looking for, it's the position. Now, if I go from the beginning, there's 2 people who have 0 siblings, and there are 3 people who have sort of 1 sibling. So my median is going to fall actually between the 2 groups here. So I have to say, well, what value is kind of going to be taken on here? Well, what's halfway between 1 sibling and 2 siblings? Well, it's 1.5 siblings. Or if we can write it like this, 1.5 siblings. So the median for this data is going to be 1.5 siblings. And then for the mean is just an average. So we know from earlier on, the mean, we know it's going to have a divide by 10 at the end because there's 10 items. But we need a way to sum up the data that's over here. So what I'm going to do is I'm going to say, look, there's 0. How many people have 0 siblings? So we're going to go 0 times 2. Plus, how many people have 1 sibling? Well, there's 3 of them. So 1 times 3. How many people have 2 siblings? 2 times 4. Let's move a little bit here. And then how many people have 3 siblings times 1? 0 times 2 is nothing. 1 times 3 is 3. So 3 plus then 8 plus 3 over 10, 11, 14 over 10, or 1.4. And so the mean or the average based on this data is going to be 1.4 siblings. So this is how we can apply the thinking from previous lessons to a frequency table. And often in exams, the data comes in a frequency table because it's just less messy for students to deal with and for teachers, to be honest. Okay, are there any questions before I move on? Okay, then I think it's time for you to fly solo, but I am going to help you with part of this. I am going to give you the data organized already. And then, can you see this lovely, this is why teachers don't like giving you a whole messy collection. Look at all these data points. It would take you so long to do that. Instead, I'm giving you a frequency table. So we've done A. I want you to try and do these questions B, C, D, E, and F. You don't have to explain what it means. I will talk about that. So I basically just want you to find so B asks you to calculate how many there are. I want you to find the mean, the mode, and the median for this data set. And apologies if it looks a bit cluttered on the board, but I'm going to hand that over to you. And then while you do that, if you are needing some help, put it in the chat or just jump on the voice note facility or voice, not a voice note, I suppose. And I can chat to you while the others are doing it. And I'm going to grab some water as well. Where's my marker? Okay, so this is number of learners on the bus. And the total sample is for 26 school days. So that's the story behind the data. How many students are on the bus? And we're taking a survey for 26 school days. Now, if you work for Golden Arrow or a bus company, this information, you would definitely do this because you wouldn't want to send the wrong size bus to the wrong place and waste money. So just give me a thumbs up if you feel like you're engaging and you're like, I'm just giving this a go. I'm not, I want to kind of know if I need to say more or if you just want the time to carry on trying it yourself. So thumbs up if you're winning, thumbs down if you want me to say something more. Okay. Elzon, are you enjoying this recap of stats? Is it becoming more clear to you? Okay. Cool. Okay. So let's have a look at this. Apologies if you need a bit more time. You can always, if you're watching in the past or in the future, you can always press pause. So use the table to calculate the total number of learners that were transported to school by bus. Well, if you think about this, there are 26 days, but that's not what it's asking. It's saying calculate the total number of learners that were transported to school by bus. So we need to know actually the total is going to be, there were 3 days with 24 students on the bus. So it would be 24 times 3. Let me just make sure I'm reading this. Yeah, because okay, the question is a little bit vague, but the way I would interpret it is, yes, if these are 3 separate days, so these students count as separate. So 24 times 3 plus 25 times 4, and you would keep going, and then you would be able to get your total as far as I would understand that. Let me actually just check. I'll check the answers in a moment. Then calculate the mean number. Well, for the mean number, you know that there are only 26 days, and then whatever total you got, you would divide that by 26. Let me actually put my, here we go. Okay. So a good way to do it would be to say, look, add an extra column to your table. And so this would be a good idea. You simply go, well, how many students in total were used doing that? And so that you get 711 as your total, or 711. Then, in order to know the mean number of learners, all that's going to happen is I'm going to go 711 divided by 26, and I should get about 27. And so the mean number of learners on each bus is 27. Now, if we're looking for the mode is actually a bit easier because the mode should be the one that occurs the most often. And the one that occurs the most often to me would be the 6. So, it would be 28. So, because that's occurred 6 times. And so the mode is going to be 28 because it tells us that essentially. Now, what about the median? Let's have a look at that. Okay, so we've basically got the answer for the mean is 27.3. The mode is 28. Now, if we're going to find the median, we need to find where the middle of the data is. And we know that there are 26 items in total. So to find the position of the median, I'm going to use my trusty formula, a half 26 plus 1. So now I'm going to go 27 divided by 2. So I get 13 and a half. So it's going to be between the 13th and 14th position. So this is where I think a cumulative frequency total would be so helpful, because you can keep track of where you are in the count. So I'm actually going to add that to my, so we have 3 here, then I have 7 items, then I have 9, then I have 13, and then I have 19. So what I'm doing is I'm adding up this, and then this, and this, and so on. Now we know that the median is in position 13 and a half. So it basically is going to be between these two categories, 27 and 28, because the cumulative frequency is at 13 and 19. And what's halfway between 27 and 28? It's going to be 27 and a half. And so that's how we use the same thinking as before. Okay, so that was a little bit more tricky. We're really getting into the meat of these questions now, but the same ideas are coming back. We're just applying them in slightly different ways for different questions. And I think the focus point in this question has been in setting out tables and then adding this cumulative frequency column when we need it, or adding an extra column like this just to keep track of what's doing. And obviously in this situation, I'm still going a little bit faster than you would have in class. In fact, quite a lot faster. So you'll have a lot more time to make sense of these types of questions. You don't have to kind of jump straight into the story. Okay, so let's do some more questions about this. And let me blow this one up. Oh, maybe I should have zoom in and move this out the way. That down, that down. Okay. I want you to find, this is going to be, we'll call this question 1 for the sake of the thing. Find me the modal interval and put your answer in fact, I'll make it A, B, C, D, E, F. Give me the modal interval from the data. This is a choir practice frequency chart. I was in the choir at school, I'll have you know. I most enjoyed it. But I fear that choirs have been a bit quiet lately since COVID started. Okay. A to F, which one is the modal interval? Ah, I love it. I see the things coming in now. So again, remember this, over a whole year, you could have 40 choir practices. Sometimes, only between maybe like 8 people arrive. And, that's almost category A, saying there was one practice where between 0 and 10 people arrived. There were 2 other times where maybe like the one time there were 15 people, another time there were 17. So we don't actually know exactly what number there were. We just know that twice during the year, between 10 and 20 people arrived at choir practice. Now, what I'm asking you is, using the language of statistics, what is the modal interval? What is, what does that mean? Which size group of people was most common? Okay. So I think, to me, it looks like 14 is the biggest number. So that means during the year, between 40 and 50 people came the most often. And so the modal interval will be between 40 and 50 people. I also just want to point out something that students get confused about, these funny crocodile mouth things. This, when there's a less than or equal to sign, it means the value could be 50. We call these endpoints. So 50 is a valid number for this interval, but 40 is not. If I had 40 people come to choir practice, I would have to be in this category here. If I have 41, I fall into this category. If I have 50, I fall into this category. And so just to remember the beginning points and end points of groups is an important idea. So according to this, the answer should be E. Okay, fantastic. Next one. Let us do this time the question is slightly different. It says find the median number of learners at choir practice. So I'm going to give you a little bit of time to think, how do you need to modify your approach to find the median of that? The median is always going to be where the middle is. Well, if it's ranked from smallest to biggest. Should I give you options again? We'll do the same options. A, B, C, D, E, F. Lock in your vote when you feel comfortable doing so. I see Chumelo is locking in some votes. Fantastic. And again, remember what I said earlier, guys, just the act of committing, even if you make a mistake, you remember more. I remember being at a university class where the physics professor kept on saying, look, we had these cards and we'd vote with like a either yes or no, or I think we had A, B, C, D cards, and we'd hold them up. And just the act of voting, he said, helps you remember the final answer more. And so that it always stuck with me. And I think it's just important to remember, just by participating, you're giving yourself a better chance of learning. You're being active. Okay, let's see. So I'm going to go back to my good old position formula. And I'm going to say there's 40 items. So a half times 40 plus 1. So position 20 and a half. Just to emphasize, this is not the value. This is the position. If I had a cumulative frequency column, I would have 1, 3, 14. Am I adding up right? Hopefully, yes. 6, 23, 37, 40. Okay. Now, I want position 20 and a half. 20 and a half falls within this category here. And so the median number or interval is going to fall into that category. And so if I want to estimate the median, okay, so this is important. If I want to estimate the median, if I'm not looking for the median interval, then obviously all I'm going to do is say, look, I don't know what number it is exactly in between 30 and 40, but a good estimating way to do it is say, well, what's 30 plus 40 divided by 2? And we get 35. And so the answer for this will be 35, or category D. Okay, so I can see some of you are still kind of getting to grips with this. So I'm going to slow down a bit. What I was doing in this question is I was trying to find where the middle is. But the reason it's so far along is the first couple of categories only have very few items in it. If you look at this 1 and 2, and then the meat of the data is sitting over here. And so to get to the middle, I actually have to move through quite a few groups to get there. And what I used to guide me was the position formula that said, look, there are 40 items. They're arranged from smallest to biggest. And then let me see what's going on. Like 1 plus 2 is 3. Then I get up to 14 items in total, go up to here, then up to 23. So I must be playing in this category here. And that's why I know I'm in that land. Now, they wanted the median number, not the median interval. And so I have to give an estimate of what the median number will be. And since I don't know where it is, the middle makes the most sense. The answer over here gives you a better sort of, and you can take a screenshot or whatever you want if you want more of a sort of a kind of detailed explanation. Okay. Now, the last one from this exercise is the mean. I want you to try and work out the mean. And I want you to remember, I'm going to give you a tip. In the previous question that we did, we made an extra column where we multiplied the number over here by the frequency here. I think we called it x times f. And so what we're going to do is we're going to add that column in, but we don't know what value to use in that calculation. So we have to make an estimate. Now, if you look at this question, the smallest value that can be in here is going to be 0, and the biggest value is going to be 10. And so what I'm going to do is I'm going to use the midpoint as an estimate. So the midpoint of this is 5. The midpoint of this is going to be 15. The midpoint of this interval is 25, 35, 45, 55. And I'm going to use that to help me work out this calculation. So my x value I'm going to use as 5, and then I'm going to times it by 1, and I get the value 5 in that column. In this column here, I'm going to say, look, I'm using 15 as my stand-in value because I don't know what it is. I'm estimating the middle. And then I'm saying, well, look, there's 2 values of 15. So what's 15 times 2? It's going to be 30. I want to give you a little bit more time to try and do this by yourself. But if you're lost, I will help you more. So give me a thumbs down if you want me more talking, and a thumbs up if you feel like you can try and find the mean number of learners by yourself. Okay, so so far I've got a thumbs up. Am I missing anything else on? Okay, Tomelo, also thumbs up. So I want you to try and find for me the mean number of learners, and then we're going to start bringing this to a close because I think time is running out. Let's do this together here. I might actually use my calculator as I go. So 25 times 11, I get 275. 35 times 9. Okay, you know what? I think we're going to run out of time today because this is a little bit more. 45 times 14. 630, and then 55 times 3 would be 165. Now, to save us, because of the time restrictions, you can always go back a little bit later. Basically, we should be getting a total for this column. You can see that we're working out here. If I add up all these totals, I get 1,420. Okay, and that's the estimate of basically the attendance. Now, if I want the average, I simply have to take 1,420 and divide it by 40, which according to my calculator should be 1420 divided by 40, 35.5. So the estimate, well, the mean, the average number of attendance, according to the mean, is 35.5 people per choir practice. If we looked at the previous one, we said the modal interval was between 40 and 50. And if we looked at the other one, our median was 35 learners. So it's interesting to note how different measures of where the middle is. We have 3 different measures and they're not always the same. And if they're not the same, that can tell us stuff about what the shape of the data is, which I will talk about in future lessons. Okay, so that is the end of today's lesson. I've got an exit ticket for you, but just to give you a little preview of the next lesson, we are going to actually move into how do we represent grouped data in graphical representations. So if you think how this course started, we started with individual data, and then we looked at calculations, and we looked at the box and whisker plot, which is the main way we represent visually individual data sets. Now, if we group data, we've done calculations today. And then we can take this information and we can make graphs. And the graphs we're going to look at in the next lesson, the one is called a histogram. And there's a little bit of work that you can do about that. The other one is called a cumulative frequency table. And so we're going to talk about that in the next lesson. So you don't want to miss out. Okay, so my exit ticket for today, I think we're running out of time. So we only got 5 minutes left. In order to bring this lesson to a close and for you to practice it, I have a quiz that I've put together. So you go to the address joinmyquiz.com and you type in this code. And I'm going to look at basically, I can see what's being done, and so can Alzan, and we'd love to support you and help you, encourage you to practice. And in the future lessons, then we can acknowledge your practice at the end of the lesson, which Alzan kind of will do when we have data on the practice. So can you just take a moment now and test this and see you can get to this quiz? And then I'll go tonight and I will check and see, okay, who's done the quiz to see, okay, are students understanding things? Are they not? And it's very helpful for me as the teacher, and it's good for you for practice. So just take a moment, check, can you go on? You don't have to do the whole quiz yet. You can do that after Alzan is finished talking to you, but just test that you can get on. If you can get on, give us a thumbs up. And then Alzan, I'm coming to you.
Awesome. Thank you so much, Peter.
Cool.
I hope it went well for all of you guys. And yeah, when you're ready, then I'll just share my screen and show the revision work.
Cool. I'm just waiting for thumbs up to see that students, if you can get on. So you may have to go to a separate app or open a separate tab, but just go to type in joinmyquiz.com and then do the code. And it should work. Let's look. Maybe if I tell you what, let me stop sharing for the second and share my browser. So then I will come to you, Alzan. So share, browser. So I want you to type in joinmyquiz.com, and you should get this lovely little animation, and then you type in 02227646 join, and then you should be good to go. Okay, so that is my little how to do. I really encourage you to practice, guys. Practice makes perfect. And Alzan, it's over to you. Thanks, that was fun.
Awesome. Thank you so much, Peter. I see that we have a few thumbs up from the learners, so that's awesome.
Oh, thanks, guys.
So guys, well done. I want to show you guys what you've already done throughout these last, I think it's only been a week. Is it a week?
It's the second week of this course. We've done 3. This is the third. Yes. Oh, okay. I changed it a little bit. So did I, can you see it? So we're still actually, yeah, we're going to get to symmetric and skewed data. We've sort of started talking about that, but we're still getting there.
Okay. So we're still busy with graphical representation of statistics.
Yeah, because we spent a bit of time doing individual and group data. I kind of hinted at symmetric and skewed data with the whiskers. today.
I
But we'll
see. Okay.
now.
Well, nevertheless, you guys have accomplished or finished your 3 lessons so far. So well done for that still. And there's 5 lessons left. So we'll see you again hopefully on Thursday so that we can continue this journey with Peter, helping us with our stats. And then also if you want to do a bit of, oh, before I go to the revision work, I just want to say the next lesson that we have will be showing the leaderboard. So this is a little man waiting for you guys to come and put your names in here. And how can you do this?
Yeah.
You can do your quizzes that Peter just showed. So yeah, just go on, hop onto the quiz like he just showed you guys and practice there. And then also the Watobe app is there for you guys to indulge in. So if you go into statistics, into the topic of statistics, then you'll find when you scroll down underneath histograms,
Yes.
and these are the 2 lessons that you guys can do before Thursday.
Yeah, that'll be perfect.
Yeah, so take a screenshot, note it down, and then that's it from us.
Cool. Thanks,
Okay,
Elzon.
guys. Thanks, Peter. Thanks,
Yes.
guys. Take care. Have a lovely evening.
Yes. Bye, everyone.
Bye.